All right, we're going to go over 7.5, ready, set, go, number 5 in this lesson. And so what it says here is they want you to use this cofunction identity, and they actually give you the identities that they want you to use, which normally, I'm just going to be honest with you, you're left to figure out which identities you're supposed to use. Okay, so for those of you who are like, oh, this is relatively easy, normally they don't give you this very first statement. They say, if you have sine of 3 pi over 10, that equals to what? And then they expect you to kind of learn this. So I'm going to start off with, let's see, hold on a second, let me move this. I'm going to start off with this right here, sine of 3 pi over 10. So I'm going to use this one because I know what it is. You can actually use this one too if you really wanted to, but I'm going to use this one. So, and I'll show you both ways just so that you can see it doesn't really matter. Hold on a second. Something's happening. There goes. All right. So I'm going to use this one right here. So I'm going to copy it up here. It says sine of theta equals to cosine of pi over 2 minus theta, right? And then I'm going to try to make everybody fit. So sine of 3 pi over 10 equals to cosine of I don't know. That's my blank. So all I'm going to do is I'm going to try to make everybody fit. So if you notice, this theta here is the guy that I'm actually looking at. So that theta is this 3 pi over 10. And then so you're just going to plug him right in there. So we write pi over 2 minus, and then I'm going to put my little, this guy. And this guy is actually 3 pi over 10. Everybody comfortable with that? So then you just do math. So then we have cosine of, what is pi over 2 minus 3 pi over 10? So this is my fraction kicking in, my fraction skills from 5th and 6th grade kicking in. So in order to add and subtract fractions, you need common denominator. So my common denominator in this case is going to be 10 and 10. So this is 3 pi over 10. And then this guy here, I need to multiply him by something so that his denominator is 10. So this is 5. So this is 5 pi over 10 minus 3 pi over 10 is going to be your 2 pi over 10. And that's my answer. Any questions on that? Any questions? Okay. Just so you know, hey, Ms. Johnson, but what if I wanted to use the other one? You can. So let's use that other one. The very first thing I'm going to do is I'm going to copy my identity. I like copying my identities first so I know this is what I'm using. This is what I'm working with. Sine of pi over 2 minus theta. And they flip-flop them. They put cosine on the left side. So I'm going to flip-flop this one too. So cosine of what equals to sine of, and then they gave me 3 pi over 10. Anybody know what to do here? Anybody know what to do here? No. Actually, so what we're gonna be doing, yeah. So hey guys, a couple people have put inverse in the chat. The only time that you're gonna use inverse is when you're looking for what angle it is. All you're gonna do here is play matching. Let's play matching, shall we? Cosine matches with cosine, yes? Good. Theta matches with whatever's gonna go there. That's the answer they're looking for. But theta is also on this side. Everybody okay with that? Play matching some more. Sine matches with sine, yes? What does that imply? Who has to be equal to each other? Ms. Johnson, I don't see 3 pi over 10. I know. So what could you imply? If this is true, who, like, I want to write an equation. That's going to be my next step. I'm going to write an equal sign. Who equals who? Play matching. Who matches with who? Yeah, very good. Can I get a couple more people doing that? That's awesome. Awesome work, sir. Very good. Anybody else? Don't wait for anybody else. This is you thinking about it. Like play matching with me. Play matching. So someone said, "Hey, Miss Johnson, is 3 pi over 10 equal to theta?" And I'd look at this and I'd say, "No. No way." Right? 3 pi over 10 doesn't equal to theta. How can you tell that 3 pi over 10 does not equal to theta? How can you tell that 3 pi over 10 does not equal to theta? It does not equal to theta. How can you tell that? Um, I'm going to put people's initials because I just want to make sure that people understand. So AA, that's perfect. Yes. Okay. Someone says, "Hey, Ms. Johnson, I know that 3 pi over 10 does not equal to theta because then who, like, look at play matching. Can you literally do that? Look at play matching. Play matching means, does that make sense? If pink matches with pink and yellow matches with yellow and green matches with green and yellow matches with yellow, what happened to who? Who is missing? Who did I ignore? Yeah, I totally ignored pi over 2. No, you can't do that. So then write me an equation that I can write. So play matching. Cosine's the same as cosine. Theta is going to be the blank. Sine matches with sine. Write me an equation. Oh, you. I forgot there's two of you. I'm sorry. Yes, you. So that's, oh, I like how you guys are figuring this out on your own. Okay, I'm going to show you matching. If this is true, then this section here matches with this section here. Play matching. Cosine, cosine, pi, blank, sine, sine, of what, same. So play matching, be comfortable with that, right? So this is called, in the land of math, this is called manipulation. So you're manipulating an identity to make it work for how you want to get it to be. So what equation should I write? So very early on, like you figured that out. That's some key information. Really good work. I can tell you've been putting in work. Easy. All right, so here, what would this equation be? Right here. Come on. So far, I only know that 2 people have gotten it. This is yours. Like you figure this one out. I promise you, I'm not worried about you or you because you showed me that this is right. Just throw an equation in there. What equation would I write next? Just try. Who cares? Be wrong. Equals to what though? You are one of the ones that I know is right. You're good. You're set. Wait, I legit want you guys to write an equation in the chat. Like legit. Write an equation in the chat. Play matching. Cosine. So like when I say play matching, do you guys realize I'm like This cosine is the same as cosine. Theta is going to be the blank. Sine is the same as sine. You guys all see what I'm saying? What's what's the blue part? All you have to do is write the blue part. That's it. So my equation is pi over 2 minus theta equals to 3 pi over 10. Where did she get that? Where did she get that? Where did she get that? Where did I get that? Yeah, because it matches. Do you see how it matches? That's all you're doing. Like, do you remember when in the other homework it said x equals to, I don't know, 2 plus I is a solution? And I said, well, if you're trying to find the quadratic, you're going to write the equation that goes above that, which is equals to 0. So you're going to try to get this equation into the form of blah, blah, blah equals to 0. This is a classic thing in math. You're getting something to look different. Like the word manipulation, I want you to think of Play-Doh. You're like pushing on it, squeezing it, rolling it, doing whatever you want to do to it to get it to look how you want it to look. Does that make sense? Yeah, that's what you're doing here. So here, when you're doing this, all you're doing is you're playing matching. So give yourself a sentence of why this is true. Why is this true? Give yourself a sentence. Now, if you don't give yourself a sentence and you just wait for me to do this, you're making it harder for yourself for this lesson and the lessons that follow. Okay. All right. So that was playing matching, and the reason why is because this side equals to this side. When you're playing matching, that's literally what you're doing. You're trying to get the equation that you're working with, aka this bottom one here, to look like this identity because the identity is true, right? So then you're just going to solve for theta here, which I would add theta to that side and subtract 3 pi over 10. So add theta to both sides and then subtract 3 pi over 10. So then my answer is theta equals to pi over 2 minus 3 pi over 10. For those of you who don't like fractions, go and review them. Because we're dealing with radians, it's a lot of fractions. So from earlier, I know that this is 5 pi over 10 minus 3 pi over 10 equals 2 pi over 10, which is exactly the same answer that I got before. Okay, so which way did you like better? Great, do that way. So I have a feeling that some of you are uncomfortable with what an equation actually means. So if I write this, like if I say 4 plus 3x equals to 7 alpha, and then next line I write 4 plus 3x equals to 28. What do you know? Wait. Yeah, alpha is 4. Perfect. Can we simplify to pi over 5? If you want to, yeah. I'd leave it as 2 pi over 10 just because, I don't know, you can, but you don't have to. You can simplify, absolutely. Yeah, so how many people see this as alpha equals to 4? Yeah, how many people? You're very good. Someone said 7 alpha equals to 28. All you're doing is you're playing matching. This matches with this. This matches with this. Therefore, this matches with this. Now, the biggest reason is because the equal to signs are in the same place too. You can't move the equal to sign away and be like, oh yeah, that makes sense, right? All right, now you're going to practice. You're going to try doing number 6. Okay, you try number 6. Legit, you try number 6. If you don't try number 6, don't expect to move further in your understanding. Okay, so some of you already got the answer, which is really good. You said the answer was pi over 6. I'm not sure. So which one would you use? Would you use this one, the one on the left? Or would you use the other one, the one on the right? Okay, people mostly use the one on the left. And if you don't know which one to use, I tend to use the one that has like, I don't know. So this is what my brain thinks. This says sine of pi over 3. Okay, now here are my choices. It's either going to be the one that says sine of theta or the one that says sine of theta minus sine of pi over 2 minus theta. Do you see how like this part here I'd have to do like some work with in order to get it to be what they gave me? Does that make sense? I want to do the least amount of work. That's what a mathematician is. They're not lazy, they're very efficient. Okay? So for those of you who are like, Miss Johnson, I've been looking for that word this whole time because that's what no, I'm just kidding. So sine of theta equals to cosine of pi over 2 minus theta. So when I write my thing, it says sine of pi over 3 equals cosine of what? So here, this is what they gave me. Sine of pi over 3 equals to cosine of what? Right? So then you play matching. Your matching goes like this. Sine is the same as sine. Theta is the same as pi over 3. Cosine is cosine. So therefore, this guy here, what color have I used? Pink. This guy here is equal to this guy here. So then, but I already know that this theta guy is this theta guy. So then I just write in pi over 2 minus theta, which is, man, Miss Johnson, theta, we already know what theta is. Sorry, trying to erase theta. There it goes. Okay, so minus pi over 3, because pi over 3 is theta. See? Play matching. And then you just do the math. So this is a common denominator of 6. So this is 3 pi over 6 minus 2 pi over 6, which is just pi over 6. So therefore, sine of theta, which is pi over 3, equals to cosine of pi over 6. Okay. These are actual identities, which mean I can actually take it over to my calculator and check my answer. Let's see. So they want me to find the sine of pi over 3, and that's supposed to be equal to the cosine, where are you? Of pi over 6. Supposedly, they are the same. And as you can see, the decimal approximation are exactly the same. Another way to check your answer is if you actually graph your function, right? And see if they intersect at pi over 6. Let's see, sine of cosine pi over 6. Where's my... Oh, I can't do it like that. Sorry. This doesn't intersect in the way that I wanted to intersect. This says sine of pi over 3 is the same height as cosine pi over 6. So I need to find... I can't... Well... If I can graph pi over 6, which would be that 0.866 guy somewhere, it would match with, let's see, we said that this was pi over 4. Pi over 6 is smaller. So let's just say it's at the closer to the top. Actually, here, let's graph pi over 6. X equals pi over 6. Sorry, I want you to see what my finger is doing. So if I click on this point here for, what is that? That's my sine. No, I want cosine of that. Sorry. Unclick that guy. I want the height to be that. So the cosine of pi over 6 is equal to the sine of pi over 3. So I want x equals pi over 3. So this dot here is the same height as this dot there. Do you see how they're both 0.5? Everyone okay with that? Yeah, that's what they're looking for. So there's a couple different ways that you can kind of check your answer. The best way to check your answer is just to make sure that you've not made any like weird steps. One weird step that you guys were trying to make over here, because this is the first time you've ever actually done this, it was say that theta was the same as 3 pi over 10. And I was like, no, because you forgot about all of your pi over 2. Does that make sense? Okay. So all of this is going to be exactly the same. Even the weirdo decimal radian ones are going to be exactly the same. When they tell you to use the radian ones, like in number 10 as a decimal, you're actually going to remind yourself what pi over 2 is written as a decimal. So when you're using this cofunction identity, you're going to plug 1.5707 blah, blah, blah into this one here to figure it out. Okay, so these ones here, same. Don't like, oh my gosh, this is so confusing. Okay, so all of these are going to work exactly the same. Yes. So if you had to look at this and pick one thing that was difficult about this, what was it? What was the one thing that was like, ugh? So someone said it's basically like substitution. It is. It is. But it's like this floating piece of information that they didn't give you in the very beginning, unless they give it to you in the very beginning, like they did here, like the cofunction identity states, blah, blah, blah. Someone asks another really good question. Someone said, so how do you know which identity to use if they don't give it to you? Right? So, like, let's pretend that they didn't give us those directions at the very top and they went like this. And they said something like, complete the statements using an identity. So what I would do is I would go like this. So this is Miss Johnson. So let's pretend I'm doing number 7. It says cosine of 2 pi over 9 equals to what? But they gave you context, right? They said sine. So I'm going to go up to all of my trig identities on my trig sheet, and I'm looking for an identity that has those two requirements. I'm looking for an identity that says cosine something equals to sine something. So I'm going to go through here and I'm looking for cosine equals to sine something. Cosine equals to sine something. And I see, no, that's not it. And I'm only really paying attention to the highlighted version because, I said so. These aren't cosine something equals to, I'm looking for, and so let's say the whole thing was highlighted. So I still don't see anything that says cosine something equals to sine something. Ms. Johnson, what about that double angle one? It says sine something equals to 2 sine theta cosine something. Yeah, but it literally has to say sine something equals to cosine something. So no, I don't want to use you. Let's see. I'm just going to keep going. I'm looking for sine something equals to cosine something. Can't see anything. I'm looking all throughout my trig sheet. And then I get down here and I'm like, look, you guys, I found it. It says cosine something equals to sine something and sine something. Oops, I crossed it out. I meant to be highlighted. Sine something equals to cosine something. This must be the identity I'm supposed to use. Okay. So for those of you who are like, Ms. Johnson, how do we know which identity to use? So I will tell you, knowing that you're supposed to use an identity is half the battle, right? You finding the identity on the sheet is just you getting familiar with all of your identities. Oh, this reminds me of that one identity that has cosine on one side and sine on the other. Wait, where is that guy? Where is he? Oh yeah. He's down here. Okay. So when you're dealing with identities, you're just looking for who is the best tool to use on this problem. Does that make sense? So if you have a nail, a screwdriver is probably not the best tool, right? It's probably going to be that hammer. But you recognizing that you need to use a tool is half the battle, right? You're not like using your nail like to screw the screw in or anything. Okay. All right. Any other questions? A couple people came up with some. So yeah, I got confused when I realized theta is talking about other parts of the equation and not just being theta. Yeah, I understand what you're saying. not just what you're taking the sine or cosine of. That makes sense. Using the right identity when we use sine of theta. Yeah. So when you're trying to, I'm just going to be honest with you, for a couple of the ones that we're going to be doing later on, if there's not one identity that you're supposed to use, there might be a couple. Meaning, like if I use one way and like John uses a different identity, and then you use like the cofunction identity, we're still going to end up with the right answer, right? If we use them properly. So it's not like, don't think that there's only one way to do it. In math, for the most part, there's been multiple ways, right? Someone said, are there going to be specific questions we can practice for using identities? Absolutely. Also, could we practice one of the set problems from a decimal radian? Yes. Okay. So let's do a radian one before we end this video. So go ahead and try number 10 really quick. Go ahead and do number 10. Just remember that pi over 2, you're just going to grab the decimal approximation from your calculator. Okay. All right, go ahead and try that. All right, so here we go, going over number 10. So I'm going to use that cofunction identity again. This one, which one are you using? Are you using the one on the right side or the left side? Sine theta or cosine theta? Which one are you using? Yeah, the right side. Now, Ms. Johnson, tell me again why you're using the one on the right side. So whenever they give me information like cosine of theta equals to 0.715, my options are, should I use this one with cosine of pi over 2 minus theta, or should I use this one where it just says cosine theta? Because as soon as I write cosine theta underneath here, you just told me who theta was by playing matching, right? So then I just have to copy the other side, which is sine of pi over 2, sine of pi over 2 minus theta. So then I just go like this, and pi over 2 is that, right? And then I hit minus, and then they told me that theta was 0.715. So 0.715. And there's my answer. I'm going to say it's 856. So this is 0.856. Done. So again, so notice how different it was from your first experience with number 5. Yeah, rounding is fine. Even if you put that, someone said, "Oh man, Michelle said I forgot to round. I put 855." I am not going to mark you off for you forgetting to round. Okay. So look at your experience from like you're being confused at number 5 to how quickly you were able to do number 10. Again, you shouldn't feel like super duper comfortable with how to deal with these identities, but at the same time, you should feel a lot better than when we first started. And this is going to be the practice as you continue to go through the rest of these. Okay. Thanks for listening.